So we have two functions. Again, no square root, so it's not going to be too bad. Give an explicit equation for the composite function and state its domain. So for A, f of x is 1 over x plus 3. That looks a little awkward. And then that gets plugged into G, and G has two x's, right? So whatever you plug into G goes in for this x, and it goes in for this x. So if I plugged in 1 over x plus 3, it will be 1 over x plus 3 squared minus 4 times 1 over x plus 3. And you have to write your final answer as a single fraction. So in this case, we would need to get a common denominator here and get 1 minus 4 times x plus 3 over x plus 3 squared. So I got a common denominator. And this I could simplify. It's going to be negative 4x, negative 12 plus 1, minus 11 over x plus 3 squared. So its domain, x can't equal negative 3, because that would cause you to divide by 0. And thank goodness they didn't ask the range, so we're not going to worry about it. Could you graph this? Absolutely. This is a chapter 2 graphing. Degrees bigger on the bottom. So you'd have a horizontal asymptote at 0. You'd have a vertical asymptote at negative 3. You'd have to find your x-intercepts, y-intercepts, and other nice points. But it doesn't ask us to graph, so we won't.
Is that supposed to be an equal sign or a subtraction?
This is subtraction. This is an equal sign. This is an equal sign. And B, f of g of x, well, g of x was the x squared minus 4x. And if that got plugged into f of x says you do 1 over, plug it in. Is it minus 3 or plus 3? Plus 3. And we have to find the domain of this. Now, in this case, this factors nicely, x minus 3, x minus 1, which is interesting because now there's two non-permissible values that don't match anything to the beginning. Our non-permissible values, x can't equal 3 and x can't equal 1. In fact, if we imagine this as functions in our function machines, first you put it into G and then you put it into F. Okay? Whatever you put into G gets squared and then minus 4x. So when you plug in 3, there'd be no problems. 3 squared is 9, minus 12 would be, negative 3 would come out. But then that would make this equation, which was 1 over x plus 3, explode. And same thing, if you plug in 1, you get 1 squared, which is 1 minus 4 is also negative 3, and it makes the second equation explode. So there are two non-permissible values in this one. Interestingly, though, you plug in negative 3 to begin with, it comes out fine. Now, there's only one question that I want to do on this one, and I actually want to do it together. So, turn to page, in the homework, question 6D.
60 questions.
6.
That's a long question.
I know.
60.
And it says that f of x, something interesting happens in this one, is 1 over x minus 1. And we want to find, they give you g of x, but then they ask you to find f of x. So we'll just ignore the g of x.
There's no point in the g of x?
Not at all. So that's the first thing that's weird in that question. They give you, and they could tell you h of x as well. Extra information you don't need. Okay? First of all, f of x is a fraction, 1 over x minus 1. And then you would have, plug that in. So we have a complex fraction, which is fractions inside of fractions, which you haven't done probably since identities. Identities, you had lots of fractions inside of fractions when you were proving things. So what do we do with fractions inside of fractions? We try to get one fraction in our original numerator and one fraction in our original denominator. In this case, I have 1 over 1 already in my original numerator. And in my denominator, I'm going to need to get a common denominator. So I'm going to have 1 minus x minus 1 over x minus 1. And then we multiply by the reciprocal. And this will be a negative x. And 1 minus, that'll be plus 2. And it does say to do the domain. So we want to do the domain. Can you see that 2 would be bad? And if you just wrote that, you would lose marks on this question. But I look at my final answer, isn't the only non-permissible value 2? It is true, the only non-permissible value of my final answer is 2. What's the problem?
We have to include a 1.
Yeah, like, if we think about what's happening here, if I draw my function machines, 2 of them in a row, right? Function f, 1 over x minus 1, and function f again, 1 over x minus 1. We can see why 2 is bad, because if you plug in 2, out would come 1, and machine 2 would explode. If we plugged in 1 at the beginning, machine 1 would explode right away. Right? Your parents would have 2 boxes in their garage that say never, ever, ever put these in.
Or just one box with those.
Or yeah, you could save some. You just don't keep them lying around because you got stupid kids, right? So we have to check every place that we divide. So if I go through this whole question, like where have I all divided? There's lots of places I'm dividing in. Any place along the way you have something that's not allowed, it's going to make your machine blow up. And in this,
Much earlier in this question, you can just see an obvious spot where x would not, where you could see x is not equal to, and be 1 over 1 over 1 minus x minus 1 over x minus 1, because just looking at that, you could probably figure it out pretty quickly that x is not equal to. Neat.
so we check everywhere to see that it can equal 1. So this one has, this is why I want to do this one, because there's 2 places that your domain can't exist. And sometimes they're like in examples on Monday, no, tomorrow, examples tomorrow, we'll see square root ones, which have a whole bunch of things that aren't allowed. And dividing, oh my goodness.